Would you still order that velvety slice of sushi if you knew it never swam in the ocean?
Welcome to Dr. Mercola's Cellular Wisdom. Stay informed with quick, easy-to-listen summaries of our latest articles, perfect for when you're on the go. No reading required. Subscribe for free at mercola.com for the latest health insights.
Hello, and welcome to Dr. Mercola's Cellular Wisdom. I'm Ethan Foster, and in the next few minutes, we're diving into a decision the FDA has just made that could change what lands on your plate. Lab-grown salmon approved without a single independent safety test. With me is my co-host, Alara Sky, ready to unpack what this means for you and the future of real food.
It's hard to overstate how unprecedented this is. Wildtype, a Silicon Valley startup, convinced the Food and Drug Administration that its vat-cultivated coho salmon is as safe as comparable foods. That conclusion rested entirely on the company's own data. No outside labs, no animal studies, no public review. Yet their pink fillets are already on menus in Portland's award-winning restaurants. And 4 more fine dining spots are queued up. The rest of the industry is watching the green light turn to gold.
If you're wondering how federal regulators waved this through so quickly, let's talk process. Ilara, many listeners have heard the phrase generally recognized as safe, or GRAS, stamped on everything from salt to vitamin C. In theory, it's reserved for ingredients that have been consumed for generations. How did a brand new biotechnological creation squeeze through the same doorway that once admitted table sugar and oregano?
Wildtype essentially wrote its own permission slip. Under GRAS, a company can declare an additive safe if the evidence is generally available. Instead of centuries of human experience, they filed a dossier the public cannot see, argued their proprietary nutrients and growth factors are routine, and sent it to an FDA reviewer who responded, "No questions." That's policy drift, using a rule made for grandma's pantry staples to approve cells multiplied with fibroblast growth factor 2 inside custom steel reactors.
And what exactly is inside those reactors? The official statements talk about a nutrient broth and a plant-based scaffold, but the recipe is locked in a black box. Even the color that makes the flesh look like wild sockeye is proprietary, as is the antibacterial wash that keeps contamination in check. One compound we do know about is FGF2, a synthetic protein that forces rapid cell division. The label won't tell you whether microdoses linger once the fillet reaches your fork.
That opacity matters because accelerated cell growth isn't neutral. Researchers use FGF2 to keep lab cultures alive indefinitely, and some oncologists watch it closely because similar pathways fuel tumor expansion. Wildtype says it rinses the cells before packaging, yet hasn't published residual tests, histology, or long-term feeding studies. The same secrecy surrounds the pink pigment. Traditionally, salmon get that hue by eating krill-rich in astaxanthin. Here, it's an undisclosed dye engineered to mimic nature without nutritional transparency.
Supporters countered that the trade-off is ecological. No nets, no feedlots, no bycatch, and thus a smaller carbon footprint. Let's examine that claim. A University of California Davis analysis measured the cradle-to-gate energy use of cultured meat and found the global warming potential could be 4 to 25 times higher than beef. If that's true for red meat, what happens when you power a bioreactor to produce seafood day and night?
The numbers get worse when you compare them with regenerative farming. Data from white oak pastures show grass-fed cattle sequester more carbon in healthy soil than they emit during life. Their net climate impact is actually negative. About 3.5 pounds of carbon dioxide pulled from the atmosphere per pound of beef sold. Meanwhile, Impossible Burger's life cycle analysis shows the opposite direction, releasing 3.5 pounds. Lab-grown salmon aligns with the latter model. High-energy inputs, synthetic additives, and waste streams nobody has mapped.
Energy aside, there's something else at play. Ownership. When the building blocks of dinner are patented cell lines funded by venture capital, Bezos Expeditions, Cargill, even Hollywood investors, that's a consolidated food system. A shrimp fisherman in Alaska can't replicate it. Neither can a family running a community-supported fishery. Control migrates from coastal ecosystems to biotech boardrooms, and you, the diner, must trust a corporation's promise that secrecy equals safety.
That concentration extends beyond salmon. The same grass shortcut has cleared plant-based burgers flavored with genetically engineered hemoglobin and dairy proteins brewed in microbes. The model is identical. File a confidential dossier, declare your novel ingredient traditional enough, bypass public comment, and rush to market. Regulators, underfunded and over-deferred to industry, rubber stamp innovations that pivot on intellectual property, not independent verification.
The health implications stretch further than seafood. Ultra-processed alt proteins often rely on genetically engineered soy doused with glyphosate. Independent testing found the Impossible Burger carried 11.3 parts per billion of the herbicide and its metabolite AMPA. They also concentrate linoleic acid, a polyunsaturated fat linked to mitochondrial stress. Clinical research now ties frequent consumption of these products to systemic inflammation and a higher risk of depression.
Combine that with unknown residuals from bioreactor additives, and you're looking at a novel exposure cocktail with no epidemiological history. We aren't talking about fermented tempeh or wild-caught anchovies. We're talking proteins spun out of stainless steel that never encountered sunlight or seawater. In the rush to scale, manufacturers may be betting that consumers will value the story, save the planet, spare the fish, over the missing data.
So, what can you do tonight when you scan a menu or browse the seafood counter? First, insist on clarity. If it doesn't say wild-caught, assume it isn't. Second, look for the place of harvest, not a marketing flourish like sushi grade or crafted in California. Third, learn your producers. When you know the captain, the rancher, or the hatchery, you inherit their transparency and can ask real questions.
Supporting local regenerative systems does more than protect your health. It keeps skills alive and ecosystems resilient. Dollars spent on a small fishery that publishes catch data or a grass-fed farm that rotates herds through living pasture send a market signal stronger than any hashtag. Those businesses list every ingredient because the ingredient is the animal, the soil, the water, and they don't need proprietary dyes to prove authenticity.
Here's the challenge. This week, choose one meal, just one, and swap any ultra-processed or mystery-sourced protein for a whole, wild option. Maybe that's sardines packed in olive oil from a fishery you can trace, or pasture-raised eggs from a nearby farm. Taste the difference, note how you feel, and share that experience with someone who thinks lab-grown seafood is the future. Thank you for watching Dr. Mercola's Cellular Wisdom. We'll see you on the next episode.
Thanks for watching. Subscribe now and click the notification bell so you never miss an update. See you in the next video.